Hello and welcome to Innovation Webinar Data Center Industry Perspectives. My name is Bhavesh Patel and I'm Vice President of Global Marketing at ASCO Power Technologies, a Schneider Electric business. I'm very excited to host another session of our Innovation Webinar, which has been consistently averaging hundreds of registrations. And I truly appreciate all of you joining us live today and hope that you learned something new. I've had the opportunity to present at various conferences, published articles, so that I can continue to add to the body of industry knowledge. And today is another such event to continue building that body of education for a typical facility's electrical infrastructure. This event was recorded earlier, but we will have live Q&A session. So the audience, please start populating your questions in the questions link of this webinar tool. Today, I'm really honored to discuss topics related to data center industry's electrical infrastructure. And I have a special guest with me, Gary Rosinko. Gary, welcome to Innovation Webinar. Can you please introduce yourself and give our audience some background about you and your work?
Thanks, Bhavesh. Great to be here. My name is Gary Rosinko. I'm a principal with KW Mission Critical Engineering. We're a specialty consulting MEP engineering firm that focuses specifically in the mission critical market and more specifically data centers. And I've been with KW for almost 9 years now.
Nice. So, Gary, you have a lot of industry knowledge through your work and the kind of experience that you have. So I think the audience will benefit your wisdom and your findings.
Looking forward to it.
So today's conversation will focus on 4 broad topics related to data center industry's electrical infrastructure. We'll start with COVID and its impact. Then we'll come into the data center facility design strategies. Then we'll touch on the sustainable technologies in data center. And then we'll finish off with digitization in the data center facilities. So Gary, let's get into the first topic, COVID and its impact on data center industry. So, obviously COVID has had a lot of challenges for many industries, and data center was no different. There were associated lockdowns that pushed most of the society to adopt or grow use of digital technologies. So that had a huge impact on data center industry. I want you to share with our audience how did this industry manage the change, as well as touch on segments that were not big users of data center infrastructure that had to quickly adopt and change their processes to start using the data center infrastructure because of these lockdowns.
Sure. So I think as probably everyone listening has experienced, back 6-8 months ago, pretty much the entire world moved online to continue managing their business. So, the use of Microsoft Teams and Zoom and BlueJeans and WebEx for online collaboration, all of these platforms, all of that data flows through data centers, whether they be individual company data centers or cloud facilities, your Microsoft Azure and your AWS and some of these other services that provide data center capacity as a service. So what we saw was really a very fast swing to where everybody's daily life transitioned onto these services, and the load on data centers and the demand for them went through the roof. And so that not just from a day-to-day life perspective, but on the data centers themselves, it put a strain on the infrastructure and the construction pipeline as well. So one of the big, impacts was seeing all these companies try to react very quickly to accelerate projects that may have been in their pipeline to develop further data center space and capacity. And what the associated impacts of that were from a construction logistics perspective. Just dealing with things like contractors on a job site needing to do temperature checks and wear masks and limit the number of people that can work in a room at the same time. It had to almost fundamentally change the way that buildings were being constructed in order to adopt those best practices and be able to react to the challenges. On your second question, or second part of the question about the industries and market segments that have been kind of forced into data centers or forced online, I think we see it in instances where small businesses that may have not even had a website before, they may have had a listing in the Yellow Pages, or maybe just a Facebook page, or an online photo of a menu for a restaurant, suddenly found themselves trying to go 100% digital, be able to do delivery and takeout and adapt, businesses in that way. And so you find that you have a lot of companies that specialize in getting those small businesses online and out to the public, whether that be something like Grubhub or, services like DoorDash, to be able to get the presence online has forced all of those companies to scale up, not just their infrastructure, but even support staff and personnel to be able to deal with help requests. So it really was a very quick turnaround and need to be able to adapt to that.
Yeah, it seems like everybody experienced some sort of a change, and everybody had to have a digital pivot, as I describe it. So with that background, power continuity is not a code-mandated requirement in the data center infrastructure, unlike, say, in the healthcare industry, where there is a compliance need that requires everybody to comply with. Also, different parts of data center infrastructure may have different levels of backup, right? If you're serving a critical load, then you may have full backup. If you're not, you may not have any backup, or you may have limited backup. Do you think that because of this digital pivot that you just described, and new people or new companies or new businesses entering into this sphere of data center environment, that this industry is now moving towards a full backup for the entire facility?
I think what you'll find, so to the first topic about code-mandated backup, there are a few instances where continuity of power and operation is code-mandated. Some instances would be a data center that hosts a 911 phone exchange, for example. A lot of that is not on a traditional phone system anymore. It's all digital. It might be voice over IP. And so the infrastructure that powers critical government functions like that, or life safety functions, does have some code mandated requirements. But what we find in general in the data center market is that the drive to provide continuity of power is really a financial requirement of most companies. So if you take a co-location company, for example, that is responsible for hosting either hosting services, individual services, or hosting, maybe data halls full of servers from a given customer. They have service level agreements that they contractually guarantee that they'll meet, and that might be 100% uptime at all their racks and 100% cooling availability within a certain ASHRAE cooling tolerance. And so what you find is that those service level agreements, if they're violated, come with a steep financial penalty that can, in a lot of cases, wipe out the profit that a company might see from hosting a given tenant or a given client. And that financial impact is a very big motivator to provide backup power and cooling in a lot of cases. There are certainly instances where backup power is not provided. A great example would be high-performance computing. So where you might be doing just intense amounts of processing, whether it be for research, whether it be looking into artificial intelligence, whether it be even something like Bitcoin mining, that a company just needs huge amounts of power, but it doesn't matter if it's interrupted briefly because the workload can pick back up as soon as the interruption is over. Then you find that facilities of that nature tend not to have the level of redundancy and infrastructure. But anything in general that's public facing, that goes out on the internet and there's an expectation that it's available to the public, you generally find that continuity is provided from a business standpoint, even if it's not code mandated.
Great. Thank you, Gary. So now let's move on to the next topic. Again, I want to remind our audience that if they have questions that they would like to ask Gary, for the live Q&A portion, please start putting them into the questions box of this webinar tool. So now let's move on to our second topic of the data center electrical infrastructure design strategies. So Gary, what are some of the key design changes that have been recently adopted by this data center industry? And the second part of that question is, are these changes accelerated or slowed in this current environment? Accelerated because they help, or slowed because that's complexity that comes with the changes?
Sure. So at a high level, there's a couple slots of data center design methodologies or approaches that you might see. And so you have the historical, what we call enterprise, or maybe your financial customers that may have been building their own facilities in the past, and those facilities would have been hugely redundant, come at great expense in order to have the maximum reliability possible. On the flip side to that, in the current market, there's been a big drive toward co-location and toward cloud computing, where that computing power maybe gets centralized in larger facilities that are designed with cost as a first driver rather than just reliability as the only driver. And that may be because there are redundant locations that can back one another up, and so the reliability of a given location isn't critical. There might be redundant applications on different servers. But what that's enabled is when we get into the co-location market and into the hyperscale market, where your really big cloud players are, the need to drive costs down has adapted to a number of different equipment topologies and ways we configure the system, all with the goal of reducing equipment costs and getting the most out of the equipment. So where you might have seen a fully redundant, what we would call 2N system in the past, where there were just an A and a B of everything, and that carries all the way down to the load, you see electrical topologies that use an increased number of blocks. So you might have a system that has 4 primary blocks and 1 backup block or reserve, where any one of the 4 primary blocks can fail over to that shared backup system. And the higher that number goes, you take a reliability hit, but the higher the number goes, the more average capacity you can utilize out of that equipment. And so instead of equipment operating at 50% at a given time, it might operate at 75% or 80 or even 85%. So your return on investment for your equipment is a lot greater. And then, as far as whether the changes have accelerated or slowed in the current environment, another one that has come out of that kind of hyperscale approach of, trading off a little bit of redundancy for maximizing utilization, has been to look at how equipment can be standardized, how the designs can be standardized, and how supply chains can be managed to be able to adapt and react on demand. So when a situation arises like COVID did, this spring, that if factories are shut down, for example, that a given company has enough of a supply chain and enough inventory in place that their next couple expansions or additions can be done without waiting on the factories to ramp back up. So you find these companies maybe holding inventory of major equipment. We might say we're going to put 18 megawatts worth of UPS and generators and switchboards into inventory. And if that design is standardized, then you find that standardized equipment can be deployed nationwide or even worldwide, with no time lag. And so you can react just in the time it takes to install equipment rather than the time it takes to fabricate and then ship and then install.
Great. So you touched on standardization and how that comes about. Let me ask you a question along those lines. So in my mind, data centers are omnipresent, right? Everything is digital in our economy and society in general. So we've kind of used this term that a hospital is a data center with patients, or a bank is a data center that manages financial assets. Even casinos are data centers that have gaming devices, and so on and on. Mm-hmm. So with that background, does it mean that a data center design can be that quote-unquote one-size-fits-all?
So I don't know that I would say one size fits all in the broad sense, but what we try to do and what a lot of our clients try to do is figure out how they can build a kit of parts for a standard design that is their starting point, and then have the ability to adapt that standard design on the fly without needing to go into getting whole new equipment designs and whole new sets of infrastructure. So, for example, if you had, I was mentioning earlier, a system where you have a shared reserve or a shared backup system with multiple primary systems, you can tailor the needs of that system based on how many primary systems are paired up with a reserve system in order to balance what your goals are for reliability versus cost and utilization. And so at its core, a financial institution that has what we call that 2N design is really, it's a reserve system where you only have one primary block. So there's one primary and one backup. Whereas a system that maybe has an element of backup in another facility, they may go to a much higher count of those primary blocks because if there was a failure, the impact is not as large. So you can see the tailoring in that approach based on the needs of the end user and the business that we're talking about. And so I think the ability to adapt is really one of the hallmarks that we see in the data center industry right now, that a certain tenant may come in and they have special requirements. They may want more than usual. They may want less. And having the ability to adapt on the fly with the minimal impact possible to your infrastructure and especially inventory that you might have is a huge component of that.
Great. So again, you touched on 2N and everything has an A and B path. So obviously, the broad topic of redundancy is a huge element for most every single data center, and you touched on that a little bit. But there has been a debate, and maybe certain industries have different view of this debate, but the debate has been that do you have infrastructure redundancy or application redundancy, where the infrastructure redundancy focuses on redundant components within a facility. So whether you have two of UPSs or two of transfer switches or two of servers or two of whatever, just like your 2N paths that you were describing. Or the application redundancy, where you have a redundant facility. So you have two data centers, maybe one in San Antonio and one in Houston. And San Antonio goes down, Houston picks up. Which of these design strategies seem to be gaining ground? And does that answer change by industry? And if so, why? Maybe I'm asking a lot of questions, but... So I think the answer to the question depends very heavily on the type of business that we're talking about. So the huge hyperscale providers that we would consider the cloud providers, like the AWSs of the world, when you get to a point where you have so many facilities and they're spread so evenly throughout the world, throughout the country and the world, that you have the ability to design your systems and design your workloads to be able to, on the fly, react to outages at a facility and offload that work pretty much seamlessly. There may be a latency hit between facilities where you were serving video to customers and you were only 100 miles away from them, and now you're 500 miles away, and so that real-time video chat may have a little bit of lag. But the big players have gotten very good and adept at being able to offload that workload between facilities. And something that's even enabled is consideration of what if we have data centers that maybe don't even have generators on site. Maybe we have dual transmission lines to a site for our redundancy, and if both of those transmission lines went down, then the work that facility was doing is offloaded to another facility. There are a couple considerations about that in terms of whether the facilities are close enough to be synchronous in real time with one another in order to have an uninterrupted transfer. Sometimes that's critical, sometimes that's not. I think if you're having a video call and the video blips for a moment, it's probably not the end of the world. But if you're processing real-time data for a self-driving car, then a 100 millisecond or a 1 second blip in that data stream could have a much bigger impact.
But the ability to do that level of scaling is really driven by the amount of facilities and infrastructure deployed. So, you may have companies that only have one or two facilities, and maybe those facilities are far enough apart that they can't operate synchronously with one another. And when you're in a situation like that, it becomes much more critical to provide that level of redundancy locally at each facility within the infrastructure component, because you may not have the ability to shift certain workload in real time to another facility.
Okay, so essentially you're saying that the choice of either infrastructure or application redundancy typically depends on the business that is under consideration. But do you see one becoming more prevalent than the other in the future?
So I think in the grand scheme of things, there's been a consolidation toward operating at the cloud level, as people would term it, and centralization of data centers into larger centralized facilities. And whether they're managed by an operator that provides services and finished products to end users versus a co-location facility that just provides infrastructure and allows other companies to come in and host their equipment. I think the trend is toward centralizing in larger facilities for workloads that don't need to be distributed. The key exception to that I would probably touch on would be as we get into higher and higher bandwidths going out to end users and the need for workload to be decentralized close to the end user. So I mentioned self-driving cars before as an example. The need to do that processing is distributed all around the country. That is an up-and-coming driver that's actually pushing in the opposite direction towards smaller decentralized facilities that can do that computing workload as close to the end user as possible to minimize latency.
Great. Thank you. Yeah, that was easy to follow. Again, I want to remind our audience that if you have a question to ask of Gary during our live Q&A portion, please start populating your questions in the questions box of this webinar tool. So now let's move to the third topic of the data center industry and sustainable electrical infrastructure. Gary, depending on which research one subscribes to, the typical data center industry within U.S. consumes about 7 to 9% of the total electrical output. And I'm sure probably similar numbers in other parts of the world. So as the data center continues to grow as an industry, as you've articulated so far, that number of electricity consumption for this one industry will also continue to grow. Obviously, the world is moving into the digital sphere. The COVID lockdown has accelerated that move. So obviously, the electrical consumption for the data center industry is going to continue to grow. So in that background, where does sustainable infrastructure fit into a data center industry?
Sure. I think there's been a pretty heavy push, especially among the large data center players, to become more sustainable. So there's social pressure on a lot of these large companies to reduce their carbon footprint and find more sustainable ways of doing things. So you'll see press releases come out where Google or Apple or Facebook will say that we're building a new data center campus and it will be 100% powered by renewable energy. And they may build solar farms that offset the megawatt capacity of the data center that's been built. They may choose to site facilities in locations that have access to hydroelectric power to be able to operate 100% on one of those renewable energy sources. So that's one way of not becoming more efficient, but finding sustainable ways to source that electricity. On the flip side, there's an ever-present drive to increase the efficiency of the data center proper, and whether that be running UPS modules in an efficiency mode or an eco mode, or running systems that eliminate levels of transformation. So whereas you might have had a power distribution unit before that stepped down your voltage from 480 to 208. You may run 480, 277 volt direct to the rack and eliminate that level of transformation. And with it, the 1% give or take loss that comes with it. And it doesn't sound like a lot, a 1% loss, but when the electrical losses in the system may only average maybe 8 to 10% from start to finish, if you can find one or two locations that you can pull 1% out of that, you could be talking, a 25, 30% efficiency improvement just on the electrical side. But the biggest thing that we have control over is the mechanical solution. And so what you see is a lot of adaptation of mechanical solutions to suit particular climates, to try to squeeze every kW that we can out of the mechanical cooling design to reduce the impact on the total load of what your mechanical load is. There's a fundamental limit as computers become as efficient as we can get them, that the computing power and the amount of work that gets done by the kW going to the computer is becoming, it's always getting better, but it's at any given time a relatively fixed number, but we have more control over the mechanical solution.
Yeah, so I have another question. You touched on it a little bit, but let me ask you a little different way. So, data center industry historically has used PUE as its efficiency measure, mostly energy efficiency measure. At the same time, different industries and different technology industries, especially all over the world, are adopting this net zero carbon footprint as a measure. And yeah, maybe net zero carbon footprint measure itself and the definition of it may not be widely known, but that is a measure that the industries globally have adopted to incorporate sustainability or sustainable technologies within their energy portfolio. So do you see that data center industry adopts something new besides PUE that includes sustainability? And if so, what does that do to the electrical infrastructure within the data center industry?
Yeah, so absolutely, we do see that change happening. And so just to take a step back real quickly for those who might not be familiar with it, PUE is power usage effectiveness, and essentially it's a ratio of the total electricity consumed by a facility versus the useful power that's going to the computing load. So if your computing load was 1 megawatt and then you had a megawatt of cooling load to condition it, then your PUE is 2. So you're saying it takes 2 times the total energy of your computing power to do the total load, including cooling, of that infrastructure. And so for a long time, PUE was deemed the metric of choice to determine, how efficient a data center was. And the result of that was, in a lot of instances, there was a push toward using the evaporation of water to lower electrical consumption. So you would find that evaporative cooling can be done very efficiently from a power perspective, but you're evaporating huge amounts of water into the atmosphere. Within the past several years, I think there's been a very strong focus on that solution as maybe not being the best solution. And I think a big driver behind that is that every day we're increasing the capacity worldwide of renewable infrastructure for electricity. But there's no equivalent to water. We have a fixed supply of clean water on the planet, and a very limited ability to just make, the use of water more efficient. If you're using it, you're using it. It does get recycled, but it puts strain on water systems. You have facilities in, let's say, Phoenix, Arizona, for example. They're in the middle of the desert, and it's a great place for evaporative cooling because the climate's so dry. But the local infrastructure and water supply is not there, and it puts a huge toll on those systems and local water utilities. So what you saw was suddenly water usage effectiveness, or WUE, came into the picture, which is I don't just want to know how efficient you are with your electricity. I want to know how much water you're using as well, because just to say you reduced electrical consumption in order to trade it off by evaporating 1 billion gallons of water a year is not necessarily a trade-off that I want to make or my end user wants to make. And so what you see now is, you mentioned carbon, and a push toward migrating all of these metrics together into a carbon usage effectiveness that looks at the bigger picture impact of both electricity and water, and what's the impact of manufacturing to make that facility happen, and how is your power generated, and try to holistically look at that big picture. And I think you're going to see an increased focus and continuing focus on that as more and more companies are coming out with plans to be net zero carbon or carbon footprint by X year, whether it's 2035 or 2050. You see companies like Microsoft making a big splash in the press saying that they're going to be carbon neutral by a certain year. And that means, following through on that commitment and figuring out how to be more efficient in every aspect of the operation of the facility, coupled with the use of sustainable energy to get to that benchmark.
Okay. So that measure, like you shared examples of maybe Microsoft or AWS coming up with that carbon footprint measures and goals, that is across the entire industry, not just limited to the data center.
Yeah, so you would find, so take a company like Amazon, for example. They're not just considering AWS as part of their corporate entity, but they're considering their delivery trucks that are running packages around the country and warehouse operations, packing those trucks. Microsoft operates more than just their data center business too. So it is a bigger picture, but from a pure power consumption standpoint, data centers are a huge driver in that. As you get into some of those other industries where you're talking vehicles as well, now you're talking about looking at electric vehicles in lieu of internal combustion vehicles. And that all goes back to the fact that the growth and the cost reduction in sustainable energy and electricity specifically has been paramount. So I think I read a study not that long ago that said it's cheaper to build a new renewable energy plant. So let's say a solar farm. It's cheaper to build a new facility than to keep operating an existing coal-fired power plant. And as that cost metric continues to skew in favor of renewables, it becomes much easier to try to transition some of those functions over to electricity, which we have the ability to continue to grow sustainably.
Great. Thank you. Thank you, Gary. Again, I want to remind our audience that if they have a live question to ask of Gary, please start populating in the questions box of this webinar tool. Now let's get to the fourth topic of the day, related to digitization in the data center industry, and touch on Internet of Things as well. Today, digitization is growing everywhere. Again, we've touched on this through the lens of COVID and the associated lockdown, but that digitization has allowed for that timely and efficient management of that electrical infrastructure. And data center industry, in my mind, is leading this evolution with DSIM or DCIM. Can you describe for our audience where this stands today, where this evolution towards adopting DSIM stands today? And has this now become a common feature across the industry, or is it still a niche application?
Sure. So DSIM stands for Data Center Infrastructure Management, and so broadly speaking, it's seen as the way of bringing all of your data on the infrastructure of a facility together to enable it to be managed as efficiently as possible. So in a typical facility historically, you might have had a BMS or a BAS system managing your mechanical infrastructure. You might have had an electrical power monitoring system or EPMS monitoring the power. You might have had some rack level climate monitoring devices that are checking temperature and humidity out in your data halls. DSIM, generally speaking, is looking to bring all of that data together into a common platform and not just make it more accessible and easy to use, but enable greater things to be done with that data. So, for example, if we see that the rack level temperatures in a given corner of the data hall are running cool, and that there's capability for the equipment in that rack to be running warmer, maybe we can ramp down the cooling in that part of the data hall a little bit and operate more efficiently. And what you see is that some of the big players that have research going into artificial intelligence and heavy computing are finding ways to take all that data and respond to it automatically in real time using AI to manage their facilities as efficiently as possible in a way that human operators wouldn't necessarily be able to accomplish. You know, if you're taking in thousands, if not hundreds of thousands or millions of points of data in real time and you're able to process them efficiently, you can make decisions down to the rack level that you would never be able to do if people had to parse that information in real time and try to make decisions about, let's make a 0.5 degree adjustment to chilled water temperature, or let's ramp down fans by 0.5%. Those real-time adjustments are enabling squeezing every percent of efficiency out of facilities that's possible.
So again, my second part of the question was, is this, you think, becoming now a common feature across the entire spectrum of this industry?
I think it varies a lot by market and by provider. So I think you would find that pretty much every data center company or operator has some level of DSIM, and it may be as simple as just having a building management system or an EPMS system that people can monitor and make decisions based upon. It could be, managing the loading of your PDUs. It could be, where to deploy new cabinets. So at a core level, even the simplest facilities usually have some level of that style of infrastructure. It's certainly becoming a very common feature in the larger facilities and the hyperscale providers and the cloud providers. The difference is the ability to take that data in and do greater things with it. As your scale as a company grows up and your ability to process that data scales up, the desire to have the data scales with it, because the more you can do with it, the more valuable it is to you.
Okay, thank you. Thank you, Gary, for lots of insights and sharing your vast experience in this data center field. Now, let us conclude our recorded discussion here and connect with the audience in the live Q&A.
Great. Thank you very much.
Thank you, everyone, for joining us live in huge numbers today. I'm Bhavesh Patel, and I have with me Gary Rosinko. Hi, Gary.
Hi, Bhavesh. How are you?
Good. So, Gary, it seems like we have an enthusiastic audience with us today. I see questions are queuing up, so I want to again remind audience, if you'd like to ask a question of Gary, please do so quickly so we can get to as many of your questions as possible within balance of time remaining in this webinar. So, Gary, let us dive immediately into the audience question. The first question is hopefully a simple one. What is the optimal voltage for data centers? And it says, can you speak to 480 volts or 416 volts?
Yeah, so I think the biggest consideration there comes down to the end user of the data center that's actually going to be doing the computing and what their hardware is geared up for. 415, 416, 400 volt, we kind of use interchangeably in this case, but that's gained a lot of traction recently, especially among some of the bigger providers, because it allows them to standardize their IT hardware globally, because in most of the world, the 230 to 240 volt single phase power is pretty common. And so that historically hasn't been a common voltage utilized, in typical distribution in the U.S. But by deploying that 400 to 415 volt power, you can obtain that same single phase voltage that most of the rest of the world is using. It gets a little trickier when we start looking at our infrastructure upstream of the computing load, because if you look at, typical North American equipment, I'm speaking from here, we're really geared up around 480 volt and 208 volt distribution. So in terms of mechanical equipment and UPS modules even, those tend to be geared a little more toward the 480 volt in and out market. There's certainly exceptions to that in terms of, taking 415 volt natively from the switchboard to the rack. And then also when we recorded the other day, we touched on bringing 480 volt native to the rack. That's one of the things that the Open Compute project has enabled. Is onboard batteries within the rack, and then you bring 480 volt or 415 volt direct to the rack and eliminate that level of transformation. So it's a little bit of a tricky answer to say it depends, but that's kind of the considerations that go into it.
Okay, great. There are a couple of questions on this next topic, so I'm going to consolidate that into one. So the question is related to alternate source of power in data centers and the primary use of diesel generators as an alternate source, but maybe more evolving use of natural gas generators as an alternate source as well. So the one question is that transition happening? And then the second part of that question is, what is a threshold, KW threshold, when the generators could be parallel or could be used in a parallel environment?
Okay, so to the first question about natural gas gens, it is certainly a question that comes up. We see a little bit of it. I think historically there's been somewhat of a challenge of natural gas gens accepting rapid load changes in the same way that diesel gens can, so that they're not necessarily as well geared toward those 100% block loads that you might see. But I think there's been probably in the past decade or so a lot of advancement on the UPS side in terms of being able to better tune to the needs of an upstream generator and reduce walk-in rates and maybe be able to adapt on the fly to a frequency group that might be coming from the generator. And I think you'll find that is probably going to help enable natural gas as a consideration on the technical side. And then the other piece of that question is, that if you look at, for example, Uptime Institute, their tier specifications, if you were to do a tier certified data center facility, they would mandate a certain amount of fuel storage on site. And so traditionally diesel has always scratched that itch, so to speak, to have on-site fuel storage. You can say whether I have a central storage tank or series of tanks, or I have individual generator sub-base tanks, that I can provide X hours of runtime on site before I need to be refueled. And so there's a question to be answered with natural gas as to the reliability of the natural gas supply and how that sits with end users. But it certainly is coming up in discussion. Even in the past couple of years, we've had several clients have asked about it. Because there are a lot of emissions benefits that can be realized as compared to, having to get a Tier 4 certified diesel generator.
Yeah, great. The next question is related to, again, COVID, the first topic we touched. The question states, all the changes that are happening due to COVID, are they permanent or are these temporary changes? And so I don't think it specifies exactly which change.
Yeah, exactly. And so I was going to say, I think it probably depends on the type of change. So there are some real nuts and bolts changes that we've seen come up in projects, like we might want an operations facility, an operations room to be 50% larger so that we can space the desks out and give people distance between workstations, or, going from a shoulder-to-shoulder open office design to either separated offices or cubicles. Whether those design features of like the people spaces of data centers carry through long-term or not, I think will remain to be seen. But one of the things that I touched on earlier was the ability to manage a supply chain and leverage, predictable inventory and repeatable designs. I think one of the things that COVID has exposed is that, there are certainly vulnerabilities in companies' supply chains and procedures and processes that were exploited or brought to light when COVID hit and manufacturing slowed down and lead times were extended. So I think some of the takeaways from that in terms of trying to standardize where you can build up your supply chains, build inventory, those things are really, they transcend just COVID, and they're really there to help with any kind of disruption, whether it be a natural disaster, some other type of interruption, a work stoppage at a factory, you name it at that point, those kind of changes can help mitigate, a multitude of risks that aren't just necessarily specific to COVID.
Okay, great. The next question is pretty broad-based, but I think it's an interesting question. Data center is becoming or has already become a utility. And similar to a typical utility, say an electric utility that has peaking challenges, right, where the entire system is designed for the hottest summer day. In the same sense, data center assets are also used such that they are used a lot during certain times of the day or certain times of the year, and then they sit idle for the rest of the time. So the question with that background is, how is data center industry evolving their designs to minimize that idle capacity?
So one of the ways from the design standpoint that I think I touched on when we recorded is that we have the ability to adjust the topology of the electrical and mechanical infrastructure. And so what you see is a trend toward having a higher ratio of blocks doing work to blocks providing backup power. So in that 2N scheme where you're only utilizing your infrastructure at 50% of its usable capacity, if you could go to a 4+1 type system, you can utilize your equipment at an average of 80% utilization. And so where reliability goals allow, you see those numbers start to creep up so that you might be utilizing your infrastructure at 80 to 90% of its nameplate rather than 50% that it might have been in a legacy enterprise facility, or even less than 50% in some instances. So I think that that's a big one on the design side. Another one that we've seen start to come up, and this is kind of enabled by some of those considerations about what you can do with the data that you're getting out of your facility, the DSIM and the real-time reaction to what your facility is doing, is some push and investigation toward utilizing all your equipment at its nameplate capacity, with the ability to quickly react to your workload and your processing load in the event that you had a failure of a redundant component. So if you had, and just to keep it simple, if you had that 2N 50% design, you could run both systems at 100%, and if you had a failure, you could react quickly enough to ramp down your processing workload before you actually realized an overload and a trip or a shutdown on the remaining system. Those kind of considerations get a little bit easier as the systems get larger and the block counts and the topology get higher, because a single failure isn't transferring 50% of your load to other blocks. It might only be transferring 5 to 10% onto each of the remaining systems. And when you get down into that 5 to 10% range, you might be within the 1 minute overload capacity of a UPS or a generator. And so you gain the ability to, as long as you can detect and react to that data quickly enough, you can temporarily take that overload hit and then ramp down your workload before you actually see another failure that cascades out of it.
Okay, so a follow-up question came to my mind. So just like the electric utility that has the rate structure designed to offset some of those peaks or motivate people to get off during the peaks, have you seen any such rate structure come out in the data center industry as we migrate more towards cloud?
Yeah, so we do have customers that deploy kind of a tiered reliability scheme where you can get different service level agreements based on the reliability that you want to pay for. So you may have your traditional service level agreement of 100% uptime, but there may be a lower cost structure available that utilizes that redundant capacity with the understanding that in an equipment failure, that redundant capacity will trip offline. And so you have no guarantee of 100% uptime, but you're paying a reduced rate to utilize that excess capacity during times when it's available, which in most cases is the vast majority of the time.
Yes, great. The next topic, we have a couple of questions, so I'm going to combine the two. and it's mostly related to remote support. So the question is, as data centers get decentralized and closer to end users to reduce latency, the competency to manage data centers of people and equipment may not be even. And the second question had the 24/7 lens to the same question about remote operations. So the key question is, do you see remote management or remote services playing an important role in data center operations?
I do, and so I think first and foremost is that most modern data centers, in the vast majority of situations, control themselves. So in general, short of maintenance or response to a failure, the systems should be configured that they're fairly resilient and able to manage themselves without outside interference. Even back in facilities designed and built 30 years ago, you already had the capability to dial in remotely via phone or via a modem and interface at a high level and just execute some simple commands. As time has gone on and technology scaled, in a modern day facility, in a lot of cases, you can have your BMS and your power monitoring systems be exposed over the internet via a virtual private network or VPN. The key consideration is typically that companies are very hesitant to expose control functionalities of their facilities out over the internet just due to security risks. So it's always a balance of convenience and remote operating capability versus security. So you find that it varies a lot from one company to the next, but if they have security procedures and secure access in place, that they're generally okay with, allowing key users to access it over a secure connection. But I think to the topic of edge data centers and the decentralized small amounts of processing, that's going to be absolutely critical, because you might have these on a random street corner, and the nearest service tech might be towns away, if not a state away, because you're trying to get them out to the far reaches of the country. So the ability for them to operate themselves, via the internal components is key. But then again, you would definitely see that remote operation capability built in when there's not an on-site staff.
Great, thanks. The next question is touching on the sustainability topic. So the question is, are there now data centers that are wholly powered with renewable energy such as solar? And maybe not just limit to your response to solar, but in general, do you think that there are data centers that are primarily driven by renewable energy?
Yeah, so there definitely are. I think I touched on earlier hydroelectric power as one potential source. That's one that a number of companies like to tout, is that they locate their facilities in places that are served by hydropower rather than coal or natural gas or diesel. So that's one. The challenge with solar, in terms of, it becomes a semantics question as to saying it's wholly powered by solar, because you could say that we generate enough solar power to offset our consumption over the course of the year. But in most of those cases, those facilities are still tied to the grid because they're still receiving energy back from the grid overnight when the sun's not out or when the wind's not blowing in the case of wind. So they'll say that, our net consumption over the year is offset by our production. But I think you'll see that we still have a ways to go on energy storage until the solar becomes 100%, your only source of power to a facility.
Okay. The next question probably is an offshoot of the sustainability topic. Severe weather seems to become more frequent event. At any given time, even in U.S. or all over the world for that matter, there's some weather event and subsequent issues challenging the geographies of the world. As we speak, there is this Category 5 hurricane impacting portions of South America. So with that background of those severe events becoming more frequent, has anything changed in the data center segment in terms of electrical reliability?
Yes, I think there's a couple considerations there. One that I always get a chuckle out of, and I think a lot of people do, is if you look back at Uptime Institute's requirements and definitions for certified data centers, they treat the utility as an economic convenience and not a requirement. Basically, assume that it's never going to be there, and if it is, that's great, but you shouldn't be depending upon it. I think that runs kind of counter to some of the sustainability initiatives that we've talked about already today, in that it places a heavy emphasis on on-site generation, most of the time diesel, which we can help mitigate that with things like Tier 4 emissions controls to reduce pollutants leaving the generators. But a lot of it can come down to siting data centers where natural disasters are less commonplace, or where there is higher transmission levels of voltages available, so that you can bring that transmission level power into the site, rather than taking power off a random 13 kV feeder that might be running down the side of the road and subject to trees falling on it. Generally speaking, the higher up in the electrical grid we can get into the higher voltages, the bigger a disturbance it's going to take to really impact that system. If you're taking 345 kV into an on-site substation instead of taking 13.2 from a local distribution line, you're talking a much bigger impact event to be able to take that transmission source down. You're probably talking a regional blackout at that point. Rather than just a local severe weather event. So I think those are kind of the two things is, looking at in areas where we do have that increased likelihood of severe weather events and disruptions, is what can we do to our generation capacity to make it less impactful if we have to run for extended durations, but then also to look at that utility side of things and figure out how we can maximize that reliability so we're less dependent on our generators.
Okay, great. The next question is a little outside of the 4 topics we covered, but I think it's an important question, and especially it'd be nice to hear your perspective as you represent the consulting community. The question is that electrical engineers are in short supply. So how is the data center industry dealing with their electrical infrastructure needs when there is a shortage of engineers?
Yeah, I think I'd probably break that down into 2 main categories, which would be on the design side and then actually on the data center operations side. On the design side, I think what we've seen of late is that there's plenty of entry-level staff available, and recent college grads, especially now over this past summer, have hit the job market, and maybe the job opportunities are not what they would have been previously. But that can put a strain on consulting firms or really any company to get bottom loaded with recent grads. Finding experienced senior engineers is always a little more of a challenge in terms of recruiting those people and getting them to where your office is if they live somewhere else, and convincing them they might want to relocate. So, one of the ways that companies deal with that is they expand their footprint and, go where the labor pool is. I think COVID's exposed an interesting opportunity with that, in that maybe you don't need to be located where your office is. So I think that's going to open up some interesting avenues for recruitment for remote positions, or maybe you come into the office a few days, 3 or 4 days once a month, or something like that, especially in an industry where you may be traveling a lot to job sites. So I'm intrigued to see how that goes as we continue going through this. Then on the data center side themselves, that can be a little trickier, because you've planted a flag in the ground and said, here's my data center, and I'm going to operate it here. And then you're on the hook to find, local talent to do that operation role. And so, they need to attract people to whatever region that may be. And some of these may not be in population centers. You look at Eastern Washington and Central Oregon, they're not hugely developed areas with huge populations to pull from. So you have to attract people to go there and work. I think one thing we see a fair amount of is a trend toward outsourcing operations and limiting the number of staff on hand. And this kind of goes back to the question about, operating the decentralized data centers with reduced staff, is that you may only have one or two people on call or on site at a given time. And so from a design standpoint, what we can try to do to help, assist with that is to simplify designs as much as possible, make the systems easy to operate and easy to troubleshoot so that, your need for significant amounts of user intervention is limited.
Great. Thank you very much again, Gary, for sharing your thoughts and your industry knowledge. We're at the top of the hour, and so unfortunately we'll have to respond to the balance of the questions separately. But again, I want to thank the audience for joining us live today at the ASCO Power Technologies Industry Perspective webinar focusing on data centers. ASCO continues to grow as a source of industry knowledge with many educational events like webinars. So we look forward to seeing you at one of our future events. For more information about our upcoming events, please visit our website at www.ascopower.com or email us at customercare@ascopower.com. Thank you once again, and have a great rest of your day or week. Goodbye.